MAN Diesel and Turbo is the global market leader for large-bore diesel engines for use in ships and power stations, and is also among the 3 leading suppliers of turbo machinery worldwide. From small gensets to 2-stroke propulsion engines for giant container ships, from emergency power generators to turnkey diesel power plants, from single compressors to complete turbo machinery trains, MAN Diesel and Turbo has the right solution for every application. Customers know they can rely on the company's engineering expertise and service support 24 hours a day, 7 days a week, regardless of where they are located. MAN Diesel and Turbo is a member of the MAN Group, a global engineering enterprise focused on 2 rapidly growing business areas: commercial vehicles and power engineering. The MAN Group has its headquarters in Munich, Germany, employs more than 52,000 people worldwide, and records annual sales of more than 16 billion euros. As the major part of MAN's business area Power Engineering, more than 14,000 employees contribute to the success of the MAN Diesel and Turbo Group, primarily at design and development centers, as well as manufacturing and assembly plants in Germany, Denmark, France, Switzerland, the Czech Republic, India and China. This is completed by a worldwide network of sales and service centers, providing comprehensive support, consultation and spare parts supply, with the aim of maximizing the effective life of MAN Diesel and Turbo's products. MAN Diesel and Turbo constantly invests in research and development to continue over 250 years of success. Hundreds of engineers focus not only on minimizing fuel consumption and lowering emissions to preserve the environment, but also on high quality and operational reliability to deliver the optimal efficiency over the entire life cycle of engines and machines. MAN Diesel and Turbo offers a comprehensive product range. Whether you require individual engines, machine trains, or complete turnkey plants, the company serves customers over a wide range of industrial applications. MAN Diesel and Turbo offers marine diesel engines, ranging from gensets rated at 450 kilowatts for onboard power to compact 4-stroke or medium-speed engines, all the way up to giant 2-stroke or low-speed engines with 87 megawatt output, as well as complete propulsion systems. MAN Diesel and Turbo's large 2-stroke engines propel large container ships, oil tankers and other vessels. The company's medium-speed engines propel all types of merchant vessels, but are also used in passenger ships, like cruise liners or ferries. MAN Diesel and Turbo also builds modern, high-efficiency exhaust gas turbochargers for high charging pressures, with single-stage radial and axial turbines. MAN Diesel and Turbo also provides turbo machines such as compressors, steam turbines and gas turbines for almost every industrial application, especially in the process industry and the oil and gas industry, for industrial gases and gas storage, for the chemical and petrochemical industry, or power generation applications. All machines can be delivered as turnkey machinery packages, together with drive and auxiliaries. Marketed under the type designation DWE, the product range also comprises reactors and apparatus for special applications, such as the production of synthesis gas for use in refineries and other chemical and petrochemical processes. The company's knowledge and expertise in industrial processes guarantee comprehensive consultation as the basis of all projects, to ensure an exact match with individual requirements. As stationary application, MAN diesel and turbo engines and turbines come into operation in power plants and emergency power supplies. The company's products range from small emergency installations to complete turnkey power plants with outputs of up to 1000 megawatt. MAN diesel and turbo engines can be operated using heavy fuel oil, diesel and other oil derivatives, natural gas or renewable fuels such as jatropha oil, tallow or recycled vegetable oils. MAN Diesel and Turbo also provides integrated solutions for the commissioning, operation, maintenance and management of power plants, ranging from commissioning services for engines and plants to the complete operation and maintenance of entire power plants. After-sales support is provided by MAN Diesel and Turbo's service outlets that are located all over the globe. These operate under the MAN PrimeServe brand. Mobile teams of MAN PrimeServe engineers are continually on alert to assist customers on site, be it on ships, in industrial facilities or power plants. With extensive knowledge and technical expertise, allied with a worldwide network of service and repair shops, MAN PrimeServe ensures quick and reliable support to minimize or avoid downtime, 24 hours a day, 365 days a year, wherever needed. MAN Diesel and Turbo uses its long-term engineering expertise as a fundament to achieve its current strategic goals: customer orientation, superior technology, profitable international growth, and sustainable value creation. And this know-how will also be the basis to serve the global trends of the future, remaining true to MAN's claim, engineering the future since 1758.
The fuel that will power ships in the future is currently very much in focus, and it seems like the development in fuel oil and gas prices, together with emission regulation, is driving the engine development. Having this in mind, I would like to welcome you to the engine of the future.
With the current rapid expansion in its infrastructure, LNG will soon become a viable fuel globally and a real alternative to diesel. Present indications are that gas applications will be installed, not only on LNG carriers where a gas supply is readily available, but in principle aboard all types of vessels. MAN Diesel and Turbo already has the technology in place for a gas-driven two-stroke dual-fuel prime mover. The MEGI engine represents the culmination of many years' work since the company installed its first prototype dual-fuel engine in Japan during the 1990s.
The MEGI is based on the well-known and proven MCME technology, which has been on the market for more than 3 decades and which has been employed in numerous applications. A key feature of the MEGI technology is the great flexibility and the seamless changeover between gas and fuel mode at any load without any loss of power.
The MEGI's super flexible fuel system can switch from operation on 100% HFO to 95% gas and anywhere in between. depending on fuel prices and availability, and therefore offers an optimal flexibility. The MEGI's combustion chamber has both a gas injection and slide fuel oil valve positioned a short distance apart, and that functions like a regular diesel engine when operating on fuel oil. However, in minimum fuel or mixed gas modes, as gas is not self-combustible, a minimum of 5% fuel oil must simultaneously be injected through the slide fuel valve to ignite the injected gas. Safety is paramount for the MEGI. Robust, double-walled gas pipes prevent gas escaping to machinery spaces, while ventilation ensures that any leaks are detected immediately by sensors and the gas supply discontinued. The pipes are then purged with inert gas while the engine continues running on fuel oil alone without any power loss. Similarly, excessive combustion pressures automatically trigger a halt in gas mode and a switch to fuel oil operation alone. Compared with HFO operation, gas gives a cleaner exhaust with negligible sulfur oxides and significantly reduced CO2 and particulates. Similarly, gas NOx levels are 15 to 20% lower compared with HFO operation, while methane slip is eliminated.
The recent full-scale demonstration test of the MEGI principle confirmed the reliability of the concept. With the first orders of the MEGI, we are now really gaining momentum in the trend towards two-stroke gas propulsion. What we see now is in fact comparable with the change that we saw more than 100 years ago when changing from coal to fuel.
I would like to welcome you to the engine of the future. The ever-growing concern about optimizing the fuel output of your marine vessel just got a head start. MAN Diesel and Turbo introduces the Waste Heat Recovery System. With the use of a waste heat recovery unit from MAN Diesel and Turbo, you will be able to recover up to 12% energy main engine power by utilizing this exhaust gas energy in a waste heat recovery system, comprising both steam and power turbines, and combined with utilizing scavenge air energy for exhaust boiler feed water heating. In the heart of the waste heat recovery system, MAN Diesel and Turbo have two ways of generating electricity: through steam productions or through excess exhaust gas pressure. MAN Diesel and Turbo offers three configurations, depending on engine configuration. ST-PT Steam Turbine Power Turbine Generator, a combined steam turbine and power turbine unit with a generator in combination with steam system and excess exhaust system on one generator. STG Steam Turbine Generator Unit. PTG Power Turbine Generator. In the modular arrangement concept, Heat Recovery Unit, or MARC HRS, consists of the desired module arranged around a generator unit. The modules consist of either the steam unit, the pressure unit, or both. For a container ship, a waste heat recovery system will in many conditions be able to cover all the electric need, and thereby otherwise save fuel that the ship's gensets would have used, resulting in high fuel savings and at the same time reducing the ship's emission footprint. When the waste heat recovery system is selected for a ship design, our main engine will be tuned for the waste heat recovery system. This means that the engine will have a bypass system which raises the exhaust temperature and at the same time enables the possibility of raising the exhaust pressure in the bypass to drive a power turbine. The water used in the steam system is supplied by the jacketed water system, When the steam is used in the steam turbine, it re-enters the system over the system condenser and back into the vacuum de-aerator tank. On the power turbine side of the system, the turbine is driven by excess pressure in the main engine bypass system. The used exhaust gas re-enters the exhaust system. From here it enters the exhaust gas boiler in the first phase. Where the gas is still very hot, the high pressurized side of the steam system is heating up through a well-designed boiler system that both keeps a steady steam level accumulated in the high-pressure steam drum mounted on the boiler unit. In the last part of the boiler unit, the gas has become colder, as it has left its thermo energy in the water pipes surrounding the boiler unit. Still, some energy is left. Though it's not able to create high pressure, the gas is used to keep the low-pressure steam accumulated energy in the low-pressure drum mounted nearby. Choose MAN Diesel and Turbo as your waste heat recovery system package supplier for single point of responsibility and a total solution for your needs. Potential fuel reduction of 4 to 12% at normal engine load. The larger the engine power, the greater the fuel saving. Emission reduction, CO2, NOx, SOx and particulates. Short payback time. The Energy Efficiency Design Index, EEDI, is conceived as an IMO mandatory instrument to be calculated and made as available information for new ships from 2013. EEDI represents the amount of CO2 in grams emitted when transporting 1 deadweight tonnage of cargo 1 nautical mile.
With regard to the G engines, there the essence is that we utilize a lower RPM. We have actually always been able to utilize lower RPMs by using our layout diagram, which is very flexible layout principles. What we do now with the G engines is that we push the whole diagram a little to the left. Thereby we get lower RPMs, thereby we can get the better efficiency of the propeller. Going from the S engine to a G engine, that means extending the stroke to bore ratio, thereby we get an engine with a longer stroke with a lower RPM. This gives also the better efficiency of the propeller.
The G-type engine has a design that follows the principles of MAN Diesel and Turbo's large-bore S-type Mark 9 engine, but whose ultra-long stroke enables the reduction of engine speed, thereby paving the way for ship designs of unprecedented high efficiency. Using the latest aft-hull designs that allow the use of larger and more efficient propellers, the new MAN B&W G-type engines will enable tankers and bulk carriers to operate at even lower speeds and fully exploit the savings potential this new technology offers. The development of the Capel propeller portfolio is the result of a concentrated body of work lasting over 2 decades. The Capel propeller minimizes the flow of water over each propeller tip, increasing the total efficiency of the propellers compared to conventional units. In combination with the G-type engine, Capel propellers can reduce CO2 emissions and fuel consumption by up to 10%. The most efficient way to increase the total efficiency of a ship with a 2-stroke engine is to utilize the engine's waste heat. This waste heat is primarily collected from the engine's exhaust gas. The MAN Diesel and Turbo developed Waste Heat Recovery, or WHR system, utilizes the exhaust gas temperature to heat up steam, which in turn drives an ultra-efficient steam turbine. When waste heat recovery is combined with NOx reduction methods, such as an EGR system, total efficiency can be significantly raised. The MAN Diesel and Turbo developed exhaust gas recirculation, or EGR system, is based on the principle of reintroducing a part of the exhaust gas back into the cylinder, thereby reducing NOx formation by lowering the peak temperature in the cylinder. In this way, up to 40% of the exhaust gas can be circulated through the EGR string of the system. The exhaust gas in the EGR string is first cooled down from 200 to 500 degrees Celsius to around 80 degrees Celsius by means of a pre-scrubber that absorbs and neutralizes sulfur dioxides and traps particles. From the scrubber unit, the exhaust gas is led through a water mist catcher that traps water droplets and prevents water carryover before the exhaust gas can be reintroduced into the scavenge air receiver. Tests of EGR units have displayed considerable reductions in NOx, with just a low penalty in terms of overall system efficiency. MAN Diesel and Turbo consistently invests in its research and development program to reduce the environmental footprint of its existing engines, introduces new, greener engines, and develops ever cleaner technologies that seamlessly integrate with its product portfolio.
In the coming years, global shipping will be facing tough challenges. Growing energy demand is pushing up liquid fuel prices, and the use of alternative fuels becomes ever more attractive. In addition, rising environmental awareness leads to stricter emission regulations, especially in the IMO emission control areas. In the future, these areas will be restricted exclusively to ships that fulfill the IMO Tier 3 emission regulation. To meet these challenges for tomorrow's shipping industry, MAN Diesel & Turbo presents its new fuel-flexible 4-stroke medium-speed engine that can be used for all applications, as a main engine for diesel mechanic propulsion, for diesel-electric propulsion, or as an auxiliary engine for onboard power generation. The MAN 3544DF. Its dual fuel technology with 2 separate injection systems makes it run on any fuel available, no matter if it's liquid fuel such as heavy fuel oil, marine diesel oil, and marine gas oil, or gas fuel like LNG. The 3544DF is based on MAN's well-proven 3244CR engine. Both engines feature a state-of-the-art common rail system with injection pressures of up to 1,600 bars. In diesel mode, this system and other technologies enable the 3544DF to fulfill the current emission regulation IMO Tier 2. To meet the even stricter emission limits of future regulation IMO Tier 3, the 3544DF can also operate in gas mode. Switching to gas can be done on the fly at loads between 15 and 100% with no loss in engine power. To ignite the air-gas mixture, a small amount of liquid fuel is injected by a separate pilot fuel system. In gas mode, the MAN 3544DF fully complies with IMO Tier 3, lowering CO2 emissions by 20% and other emission levels by up to 99% and beyond, compared to liquid fuel operation. In addition, using gas as fuel also provides substantial economic advantages. Over the past years, the price difference between liquid and gas fuels has increased steadily and is expected to keep growing. As fuel makes up the largest part of ship operating costs, reducing fuel expenses is the most effective way to keep shipping affordable. Already now, using natural gas as main fuel enables ship owners to save fuel cost in a double-digit percentage compared to a conventional diesel engine. When looking at total operating cost, the savings potential becomes even higher. The MAN 3544DF allows ship operators to fully harness this potential, plus the flexibility to switch between fuels at any time for optimum resource utilization. For sustained operation on a wide range of gas qualities, the 3544DF features a fuel-sharing mode. In this mode, both gas and diesel supply systems are active, which lets the engine run on multiple ratios of gas and liquid fuels. This makes the 3544DF virtually immune to variations in gas fuel quality, allowing it to operate even on gas that would be unusable for a conventional gas engine. Highest power output in its class, compliance with IMO Tier 2 and Tier 3 without aftertreatment systems, low operating cost, due to affordable gas fuel, complete fuel flexibility, a robust design based on proven engine technology, the ability to upgrade IMO Tier 2 compliant 3244CR engines to dual fuel operation entirely on board, and an increased vessel resale value due to an engine that fulfills all regulations for many years to come. All this makes the MAN 3544DF the perfect choice to keep cost of ownership down and give ship operators the flexibility and sustainability they need. With the 3544DF and the larger 5160DF, MAN Diesel and Turbo offers its customers a complete range of fuel-flexible 4-stroke medium-speed engines that fulfill all economic and environmental demands of tomorrow's shipping industry today.